Good evening, everyone. Welcome to the BRLSI. I'm Tony Symes, and normally I organise monthly lectures for the Herschel Society. Tonight, though, I'm standing in for Jackie Hill-Murphy, who's away, and Stuart Reynolds, who was going to stand in for her, but is now suffering from a nasty cold. The title of tonight's lecture is Climate Change and the Global Wildfire Crisis, and the lecture is Professor Stefan Doerr. But back to tonight, and Professor Stefan Doerr is based in the Geography Department at Swansea University. He's a professor of wildland fire science, studying the effects of fire on landscape, soils and water, as well as global fire patterns and trends. He is editor-in-chief of the International Journal of Wildland Fire, and he's going to talk about his work, which has led him to being awarded the prestigious Murchison Award by the RGS. Over to Stefan.
Well, thank you very much for the introduction, Tony, and a warm welcome to you and everyone online. Now, I'll probably start with a small correction. This is mainly a general talk and a little bit of our work at Swansea, so I'm digressing perhaps a little bit from what you might have expected, but I think you'll probably find this more interesting than my specific work. But I will digress into this a little bit once in a while. So wildfires is certainly not the kind of day where one might think about wildfire. But yeah, this presentation is essentially about trying to unravel myths or perceptions from reality, or realities, different realities. Different people might have different realities about wildfire. And I'm not on social media very much, certainly for work, but I've actually posted this, the talk this evening, the advert for this on LinkedIn. I don't use LinkedIn very much. And the question of whether there is a global wildfire crisis was answered straight away by a colleague in Australia, a wildfire scientist, and their answer is no. Not so sure whether that's the case, and in fact, I didn't say anything about a global climate crisis, but here we are. You know, global, social media tends to fire quite quickly. But let's unravel this a little bit. I don't want to stop the talk now because it's answered. I want to delve into this a little bit more and just see, you might have a different view on this. You might have different views whether or not we have a global wildfire crisis. So let's dive into it. Most of you are probably not academics. There will be some academics here. Well, there's certainly one I know, and there may be some online, so you have to forgive me if I simplify everything a lot. But basically, the perception that you have about wildfire is likely to be driven by the media. Perhaps you read some more specific articles about this. But the kind of things we tend to see in the media, they speak for themselves. So I'm just going to show you some slides without saying very much about them, the kind of things that we associate with wildfire. And that's been over the last decade or so. Some of you might remember those events. This particular one, the Palisade wildfire, was actually the most expensive wildfire in American history until this year. Black Summer just before COVID, you might remember that as well. It really hit the news quite extensively. Canada was in the news this year, of course, as well as last year, but 2023 was the fire year for Canada. And the reason it was in the news, probably more than anything else, was the smoke in the United States, the east coast of the United States. They complained a lot about the exports from Canada. No tariffs at the time. This also hit the news not only because it was the largest wildfire in Europe, but also there were a number of evacuations affecting British tourists, and of course, that is a disruptive aspect. No British tourists got killed, but nevertheless, it was quite an extensive fire season for the Greeks. Very tragic, a relatively small fire leading to the largest death toll in a century. And then, of course, Los Angeles. You probably will remember this. This year, in January, the news was full of the LA wildfire and 20 billion of insured losses. That's not counting any other losses. So far, the most expensive wildfire, probably ever, depending on what you consider expensive. Now, I haven't seen much about wildfires in the news recently for the last few days. I'm not sure whether you've seen anything. Are there any fires around the world at the moment? There are. You can actually look this up on a daily basis where fires are in the world. It's this basically satellite detections of fire. There's fire all over the place. We are currently, obviously, in the northern hemisphere. Autumn, not the main fire season in the northern hemisphere, but you can certainly see that in the savanna regions of Africa, for example. This is the main fire season. We also have a lot of fires in Australia, but also India, Southeast Asia, Amazonia, plenty of fires there that we do not hear about in the news. And I have to admit, this is a little bit misleading because it looks like all of Madagascar is burning. Well, that is not the case. This is simply how the data is being displayed. So if we zoom in, it would look more like this. And if you zoom in further, the fires would even be smaller. But in order to display this, each fire detection over a certain size is given a pixel, basically, in this. And it just gives you an idea about the global distribution of fire. You can do that every day. I'm sure you have better things to do, but you could look up every day where fires are burning. And again, most of them will not be in the news at all. But really, fire is nothing new on Earth. So this is the picture as of yesterday. But globally, we've basically had fires on the land surface since pretty much we had land plants on the surface of the Earth. So fires are really common. So we had them for more than 400 million years. Many plants have co-evolved with fire. And currently, fires burn roughly 7 to 9 million square kilometers of the Earth's surface every year. That's a lot of vegetated land surface. It's 6% of the ice-free land, and there are plenty of land that doesn't support fire, like the Sahara Desert, for example. So you can imagine there is plenty of fire around. And again, very few of these fires will hit the media and will hit the news. This area is roughly equivalent to about 30 times the UK land area, or a little less than Europe. So it's a vast area burning every year. Now, how does that happen? How do fires start? Now, again, if you believe social media, that is a major cause of wildfires. That went around the world during the LA fires. Lots of conspiracy theories. The government was responsible for wildfire because they benefit from this. There's lots of stuff going around with social media, of course. And no, of course, this is not the main cause. But I think this was a really interesting news piece. Yes, we humans are responsible for many fires around the world. In this particular case, 14 fires were basically started by a climate conspiracist. So that's an interesting twist in that story. But let's have a look at fire starts around the world. What is starting fires? What is causing fires in general? And of course, the main cause of fires, of wildfires, is lightning. Now, in the UK, we don't have a lot of lightning, and when we have lightning storms, they're often associated with rainfall. So our perception, I'm from Germany, my perception is the same thing. When there's lightning, it rains. That's not going to start a fire. But if you go to more continental areas, you often have dry lightning, or even if there is some precipitation, lightning can still start a fire. So before we started meddling, let's call meddling with fire, let's say using fire, that was the main cause of wildfires around the world. Nowadays, things are a little different. Lightning is still the main cause of wildfires in remote areas, or at least many remote areas, but of course, we are the main cause of wildfires in most more densely populated areas, including the UK. It could be accident, it could be arson. You might be surprised to hear that electricity lines, power lines, are very often responsible for fire. Again, this happens in Europe, but less so in Europe, but Australia, United States, especially California, it is a major cause of wildfire, and it's also a cause for major electricity companies to go bust. But there's a third cause of, shall we just say, vegetation fires. We've long managed the land setting in on fire. So, for example, here on the left-hand side, this is savanna grassland that is ignited to basically maintain the grassland, improve grazing, but also it's been used for hunting for many, many millennia, basically. But also this example here is from the Brecon Beacons National Park. This is a purpose fire. The landscape is set on fire, very mild fire, to improve grazing, so that maintains the landscape. Heathlands, heather grasslands, for example, or heather lands in general, but also a combination of heather and grassland. They're often managed with fire, because if fire wasn't there, or we wouldn't manually cut the heather, it will be replaced with a different vegetation. So we've long used fire to maintain the landscape. Now, you can argue whether these are wildfires or not. Let them just call vegetation fires. But in terms of actually the fire process itself, let's just think about fire in general, not just landscape fire, vegetation fire. Let's think of fire itself. What we need is obviously oxygen, plenty of this in the atmosphere, 21%. There was a time in the past when oxygen content was higher. We actually had more fires in the landscape than we have now. You need fuel. Now, fuel, we usually think of gasoline, diesel, petrol. But of course, vegetation, when it's dry enough, it can burn. If the vegetation is dead, like grasses, for example, if they have a little less than, say, 40% water content, they can burn. Okay? So when vegetation is dry enough, it generates fuel. And let's just stop here for a moment, given it's close to Christmas, and let's just have a look at how a fire actually burns. Now, excuse me, I hope the fire alarm won't go off. It's just a little experiment here, but we're all very familiar with it, and that's probably very fitting now for Christmas. Here's a lighter. It contains butane, and there's a flint in here, and it works. Very simple. We do it all the time. Very simple. In order to ignite this flame, we need about 360 degrees to do this. No problem. The spark will do this. Now, we all lighted a candle. We can do this now with 360, well, the ignition of the flame is 360 degrees. The flame itself has over 1,000 degrees in essentially the upper middle part. Whether it's a wildfire or this little flame here or this candle now, it's the same. The temperature in there, in the middle, is over 1,000 degrees. In a wildfire, it'll be the same, except, of course, the energy release from that flame is tiny, whereas the energy release in a wildfire is much bigger. But let's stick with the candle just for a moment. I might ruin your next romantic dinner here, but if we think about it, we have here a solid fuel, okay? Now, can we burn wax? Actually, I'm not going to make a mess here, just very briefly. It will not ignite. The wax is actually not burning. What about the wick? Wicks are often made of cotton, and they have wax inside. What would happen if I cut off the wick, put it on a table or a plate, and burn it? It would burn, but it would burn completely. It would be gone, right? Now here, the wick is actually, is it burning? Well, it looks like it's burning, but it's actually not. If the wick itself was part of the fuel that's consumed here, it will be consuming, and the wick is not being burned. Ultimately, it will disappear as the candle disappears as well, but at the moment, the wick is not burning. So what is actually burning? Is it the wax burning? Well, in principle, yes, but in practice, it's the gas that is basically generated here in the wick. So the wax is melted just at the right temperature. Capillary reaction drives up the molten wax. On the surface of the wick, the wax is essentially evaporating. Not quite the right term, but let's just say it's turned into gas, and it's the gas that's burning here. So it's essentially the same as this, except a little bit more complicated in terms of what's going on. So the candle is really a fascinating design, and that you can actually listen at major lectures on the candle itself. So I keep it as short as this, and I'll leave that for now. But essentially, the same thing is happening in a wildfire. We have solid fuel that is turned into gas, and it's the gas that's actually burning. It's not the fuel itself. Of course, it looks like it, and for all practice purposes, it's actually irrelevant, but that's the main thing that's actually happening in a wildfire. We do need those roughly 300 degrees to be able to ignite a fire, and we need enough energy to turn what is in the wood or in the grass into a gas form through pyrolysis, and then it can burn. Otherwise, it will not burn. Okay? So that was a little digression into how we can actually set things on fire, or how it actually works. But what are the impacts? Now, of course, the fuel, the vegetation, will be, let's just say, harmed or destroyed. When you often get this phrase in the media, so many hectares of acres of forest destroyed or lost. Now, I'll come back to that in a minute. But here's an image I took out of a helicopter some time ago in Canada. This is a boreal conifer forest in northwest Canada in the Mackenzie Mountains. It's a few days after fire. I was actually there on holiday. I had nothing to do with fire, but I'm glad I took this picture because it gives a good example. And so what we see here is essentially a burned area. All those trees are dead. Some of the trees are brown. They basically scorched. They will also die. All the others are surviving. And this is called a stand replacing fire. Stand means all the trees are dead, and they have to regrow from seeds. Now this is perfectly normal in this environment. So in this environment here, we would have a fire typically every 130 to 180 years, roughly speaking. Varies with different areas in the Boreal region. And what this does, it actually enhances species and age diversity. That environment is adapted to fire, and it basically, I wouldn't quite say protected, because of course the trees are dead, but the trees are regrowing. It's perfectly normal in that ecosystem. And the fact that we have a patchy area here that hasn't burned for a long time, we have an older area that hasn't burned for even longer. Here we see some younger forests, and all this is very patchy. And essentially this is just a normal, healthy ecosystem, even though to us it looks like it's heavily damaged, which it is in principle, but in terms of the overall health of the ecosystem, it's actually normal. Let's go to Australia now. Australia 2009, the Black Saturday fire. You may or not have heard of it. This was the deadliest wildfire in Australian recorded history. Over 170 people were killed in this fire. And we did some work above a town called Marysville, where again, quite a number of people were killed. And the severity of the fire, the damage was basically off the scale. You can see this looks like Armageddon, essentially. Terrible, looks really bad. We had a field site here and quite a few other places we instrumented. And I'll just show you what this looks like in 2016. Almost all the trees have survived. These are not stand replacing fires, and this is normal in Australia. They tend not to be stand replacing. The biomass in this is nearly what it was before, and the fuel in terms of flammability of the landscape is probably now higher than it was in 2009. And how does this work? Well, the eucalypts, not all of them, but most of them, there are over 500 species that have a trick up their sleeve. And this is what's called epicormic growth. They can basically put out those leaves straight from the bark. So even if the small branches have been destroyed in the fire, they can basically regrow the leaves very quickly. And within weeks after fire, you see these green growth. So the trees still look a bit damaged and shaggy in a way. But from an ecosystem perspective, again, that is perfectly normal, even though it was a very extreme fire. There's some other plants in Australia, but also elsewhere, that have been very well adapted to fire. And one adaptation is what's called serotiny. So here we have basically a seed pod, and I brought you one. You can pass it around. Connected for Western Australia. So these seeds, they open under heat, and this is not unusual for many plants, and they take advantage of the fire. The seeds will fall out, they fall onto the ground. The competition for light and water and nutrients is minimal. So it's an ideal scenario to thrive. So these plants are called pyrophytic, fire-loving plant. And this is also typical for some pine species. So these plants are very well adapted to fire. So if you look at the environment in general, we talked about the boreal forest, we talked about Australia. So in terms of forests, recurring fires are normal there. They maintain some ecosystems. So basically in the boreal forests, western United States, where all these extreme fires seem to be occurring, in the Australian forests, in southeast Australia and southwestern Australia, we have what we call infrequent fire. Every 30 years in some areas of Australia, near Sydney, for example, up to perhaps every 180 years in Siberia, parts of Alaska, Canada. So this is a fairly normal thing. In savanna, it's even more extreme. So African savannas, Australian savannas, you get fires every few years, in some cases virtually every year. So fires there are very frequent. Grasslands are extremely adapted to fire. In fact, they're maintained by fire. So it's both grazing and fire that maintains the openness of these savannas. But there's also other areas that are not fire adapted, and this is the tragedy in this, and this is something we also often hear in the news, heavily discussed, of course, at COP as well. Tropical rainforests have no adaptation to fire. So if they are exposed to fire, they suffer, basically. So we often have irreversible ecological damage. Sometimes fire is used to simply remove the forest and then have grazing, for example, have cattle there, or also replace it with other plants. And of course, we have a lot of greenhouse gas emissions, carbon and other emissions from those fires. And we also have the loss of, for example, the carbon sink and of course, ecology, species, and so on. So really, for rainforests, there is no adaptation, and there should be no fire in rainforests, but unfortunately, there is plenty of fire in rainforests. And then if we go back to those world's fire-adapted forests, for example, we can also have too intense fires or too frequent fires. which can then cause long-term damage to the ecosystem. That was one of the concerns in the Canadian fires as well as the Australian fires, the Black Summer fires, that it was just too much fire basically, and the ecosystem will take a long time to recover, or certainly longer than is normal. So again, we expect here some loss of the carbon sink. Of course, there are also other impacts of fire, and some of those, I'm digressing briefly in this kind of work that I've been done over the years. One of the aspects I've been working on in my early career was actually something called soil water repellency, something rather bizarre, but you know, when you're outside with your rain jacket and it works really well, the water will just repel off, it'll just run off the surface. The same can happen in a soil. If you heat a soil above a certain temperature, it becomes water repellent, or it can become water repellent. And again, I have a little bit of show and tell here. So some of you might be able to see this when I pass this around. Here we have a soil, and apologies for the ones that are online. So here we have a water repellent soil, and what you normally expect from a soil, you put some water on it, lift this up a little bit, you put water on the soil, and it should go in. And it doesn't. It just sits there. You probably wish your rain jacket was as good as this. I'll leave that here. No, I'll pass it around. With the bottle, you can play with it. Now this happens typically during wildfires, but in fact also if your rain jacket isn't as water repellent anymore as it was, you can put it under a tumble dryer at about 40-50 degrees and it will improve its water repellency, at least for some time, but I'm digressing. Let's get back to soil. Now, why is this important? It can basically remove, well, it can reduce the infiltration in the soil, and if there's heavy rainfall, what we'll then get is basically enhanced surface wash, and this surface wash can, of course, enhance erosion, and this can lead to debris flows, for example. Here an example from Canada, or here an extreme example from California, where there were 23 fatalities outside of a burned area, but below a forested burned area, and it was some months after the fire. So this is a perhaps somewhat unusual effect of fire, but there are deaths from this particular impact of wildfire. Now this will wear off after some time, so 2 or 3 years later the soils become more normal again. And there are also other impacts I'd like to cover very briefly. So yeah, this is what typically happens after fire under extreme circumstances. But then also you have a lot of ash in the landscape after fire. Now this is a good thing in a way because ash is rich in nutrients, it helps basically regrowth, but also if this gets to the wrong place in water bodies, it can be a problem. So with this enhanced erosion, this enhanced surface wash, which is not only driven by water repellency, it's also the fact that the protective vegetation is gone, this ash can end up in the reservoirs, can lead to algal blooms, and in the end you can have fish kill. So this is again not that unusual after fire. And as far as we're concerned as humans, of course, this is something that would worry us, but there's something else. If you're a water supply manager, this will be a headache for you. So for example, here in Canberra, in Australia, huge costs directly related to wildfire, big impact. And this is quite unusual these days in a Western country to have forced water restrictions because of wildfire. And this is not limited to Australia. Saddleworth Moorfire, for example, some of you might remember that 2018, the army got involved. It burned for over 3 weeks. It was near Manchester, and it affected one of the drinking water reservoirs of United Utilities of Manchester. So they were rightly quite concerned what would happen with this ash if it was transported into the reservoir. And this ash in particular is one of the most contaminated ashes that we've investigated. We did a big data set on global ash composition, and this is very contaminated because it's basically downwind from heavy industrial activity from the last century, well, the last 2 centuries really. We have the same problem in South Wales, a lot of contaminated land. So in this case, the metal content is relatively high, heavy metal content is relatively high. In the end, it wasn't a problem, but this could well be a problem. So let's just have a closer look at the UK, fire in the UK. You may be aware of wildfire in the UK, basically. But of course, our firefighters, they're usually busy with flooding. We definitely see more flooding in the news than we see wildfire. But actually, wildfires do occur. We have about 30,000, let's just call them vegetation fires in the UK every year, more or less. Some years more, some years less. Most of them are really small, but nearly all of them are attended by the fire and rescue services. And if you look at the record overall, this is a record of just the large fires that can be detected by satellite over 20 to 30 hectares. You can see there are quite a few of those, and it varies. So, for example, 2024, very, very few fires. 2025, the biggest fire year we have, at least since we have satellite records. So lots of fires. So basically the fire services were really, really stretched this year. And you remember, this year was relatively dry in spring as well as the summer. Now, let's come back to the bigger question. This is just a little introduction to fire. Do we actually have a global wildfire crisis? Well, about 10 years ago, a colleague and myself were asked by Lloyd's Insurance, they don't only do normal insurance and do bank accounts and so on, they are a global reinsurer. So they basically provide insurance for other insurances. It's a big business, basically, and very expensive. They asked us to do a report on what the trends are globally in wildfire, and of course what the risk is for business. And so here is a question mark then, a burning issue for insurers. Is it a burning issue, wildfire? Well, so at the time we basically looked at the available literature and reports and data and so on and put this report together, and we actually felt there were quite some surprises in there, and we then took this a little further and published it as a scientific paper, and the title was basically Global Trends in Wildfire and Its Impacts, Perceptions versus Reality in a Changing World. So it's a little bit like what I'd like to talk about now, the title of the talk. And one of the things, let's come to one surprise really here. It had 50,000 downloads. Now for scientists, this is amazing. 50,000 may not sound very much, but for scientists, like, wow, we've done such a fantastic job, we educated scientists and maybe others, maybe the media and so on. Thought we could really be proud of ourselves. And one of the many things that we highlighted in this was a rather surprising finding, which scientists really knew, but the general public, insurers and so on, and also the media didn't really know. And this is essentially that the global area that's been burned, the overall area burned, has basically declined since 2000. So this is basically the data we had until then, 2015, and this trend has continued. And the author of this is in the room, Matthew Jones, here in the back. This is one of your graphics. So basically we have this perhaps really surprising decline in wildfire globally. That was just one of the findings. And we did also go into the details why this is. But basically, this is why our paper got downloaded so many times. Nobody really read it. I'm not saying nobody. The media really didn't read it properly. They just looked at a few headlines, and the headline is wildfires declining globally. And so this is the result. Heat receipts for wildfires, global warming isn't causing more wildfires. Forget the Amazon hype. No problem. Climate change doesn't exist or doesn't make any difference. If any of those journalists had read our paper properly, they would have not said this. This wound me up in particular. It's a German magazine, highly respected, and they're saying forest fires are getting smaller. And in fact, forest fires are not getting smaller. Wildfires in general are reduced, except in forests. But hey-ho. Anyway, we were very upset about this, as you can imagine. This is not really what we wanted. But since then we've tried to improve this, and what we should have done is actually be a lot more specific right away, right at the beginning, in our abstract to explain what was going on. But let me explain what has been going on. And again, this is data that Matthew Jones has basically led the work that put this together. Globally, we do see this decrease in wildfires. But of course, it's complicated. And this is what every scientist would tell you. The reality is always more complicated. So here we have Alaskan forests, big changes over time from 2000 to 2020, up and down, but the general trend is not much change, just some extreme years and less extreme years. Pacific Canadian forest, Eastern Siberian forest, whoa, we see quite a substantial increase in fires. And this is actually true in most, but not all the forest areas around the world, but most of those. Okay, so we actually see an increase in forest fires in many areas. But, and this is the big but, Northern African savannas, Southern African savannas, a huge decline. And the African savannas, well, Africa in general represents about 70% in terms of area burned of all the wildfires around the world. So if you do an average, you will see a decline. But the silly thing we shouldn't have done is actually to even do a global average, because it's not really that relevant. But there we go. We live and learn. So basically what we've seen is the last 2 decades, we have a big difference in trends, in burn trends between regions. So Northern African savannas, 41% decline. And this is largely due to human land use change. Not only, but primarily, the land changed to less flammable land due to us. Nothing to do with climate change, nothing to do with less probability in terms of the landscape burning. It's just we remove the fuel, therefore there's less burning. Forests, Western North American forests, 54% increase. Eastern Siberian forests nearly doubled. And this is essentially where those extreme fires are occurring in terms of environmental damage, death toll, carbon emissions, and so on. So basically, if you want to summarize this quickly in a very simplified way, we're losing those ecologically important fires in global grassland, and we see an increase in extreme high-impact fires, even though the average gives us a decline. Okay, so this is basically, in a very simplified way, what's been going on. Now, is global warming responsible for this? Of course, not the decline, I already said this, but is global warming responsible for the increase in fire around the world? And with this, let's just have a look what climate or weather actually does to fire. I said earlier, to ignite a fire, the fuel or the vegetation needs to be dry enough. How does it dry? It needs to be warm, but primarily it needs to be dry. The weather needs to be dry, low humidity. One of the biggest fires we had on record has actually been in February in Scotland. You think, well, February? It just needs to be dry. Some of it burned over frozen ground. So if we look at the impact of climate change on what's called fire weather, and fire weather is not just the weather on the day, it's essentially the weather conditions that have led up to a day where, let's say, the landscape is flammable, not flammable. So how much rain was there recently? Does it allow the vegetation to dry sufficiently? If it's very warm, of course, the vegetation dries more quickly, but the precipitation and the relative humidity is actually more important here. And again, work led by Matt here in the audience, put you in the spot quite a few times today, examine the change in fire weather season length. So how many days per year in a given area is the season okay for fires? Is it possible to ignite the fuel? That's essentially the length of the fire season. And so this would be a decline in fire season length, fire weather season length, in number of days. This would be an increase. Now, blue is decrease, brown is increase. There's not a lot of blue on this graph. So basically, we're definitely seeing an increase over the last 40 years in the length of the fire season. Some areas, some people are now saying, California, for example, fires year-round. Some areas in Australia, they're arguing fires year-round. Whether that's exactly true or not is a different matter, but clearly the fire season length has increased virtually everywhere, especially in the Mediterranean, for example, and this is one of the fastest warming areas on the planet. And of course, also some northern latitudes are warming very rapidly. Now, this is not the whole story, though, and especially in Europe, but also other parts of the world, it's not the whole story. It's not only climate change, but we also have a more flammable landscape in many regions because of our activity, or if you wish, inactivity. Especially in the Mediterranean. Here's a map on the left of the Mediterranean. Portugal really stands out, and Portugal is the number one in terms of wildfires in Europe, followed by some areas in Italy, Greece, and also Spain. And this is an image from Portugal. I did my PhD in Portugal on these weird hydrophobic soils, so I'm quite familiar with the region there. And 40, 50 years ago, this landscape would have looked very different. It's now forested with pines, very flammable, eucalypts, very flammable, shrubs, very flammable, and where the landscape in the past would have been intensely cultivated, there would have been wine, there would have been sheep grazing, there would be grazing even in forest. If there was forest, was a lot of oaks at the time as well. Oaks are flammable, but nowhere near as flammable as these forests. So basically this afforestation has led to a much more flammable landscape, but also generally the depopulation in rural areas, reduced grazing, and we're actually seeing the same in some areas in Britain. In South Wales, we have plenty of forests. We're leading actually in South Wales. That's where I'm from, Swansea University. We're leading in terms of area burned per population, unfortunately. But anyway, I'm digressing. But what we have is far less grazing than we've had in the past. So the stocking density of the land is much lower, grasses are much more dense, we have more gorse, and so on. So the landscapes become much more flammable, irrespective of climate change. So this is one other important aspect to consider. The other thing we have, and I'm not going to cover this very much, but I'll digress into this briefly later on, we had very aggressive fire suppression, keeping fire out of the landscape in landscapes that are adapted to fire. This has happened in Australia. Aboriginal burning was banned, for example. This happened in North America. Fire was considered the enemy, so the fire was basically trying to be suppressed in forests. Didn't work everywhere, but in many areas it did work, And that meant we have more and more flammable vegetation accumulating, and then when it burns, it really burns. So this is another problem. And there's another problem on top of all this. More people living in areas that are flammable. That increases the ignition risk, just because people are there, and that also increases the danger to individuals. So if you're an estate agent, you probably think, wow, this is amazing. This is on the outskirts of Barcelona. This is the Western United States. Amazing. What a nice place to live. If you are a fire researcher or an insurer, this is a nightmare. This is not what you want. And of course, who is right? Both are right. It is fantastic so long as it's not burning. It is a nightmare when it burns. And in fact, it is burning here in the background. And I came across this in the news. That was a few years ago now, but I use it a lot because I think it really puts it on the spot. The phrase here, wildfire is pushing into 2,000 backyards. Yes, it is. But actually, the backyards are pushing into wildfire. That's exactly the same thing, but human-driven in a sense. And in fact, in the United States, the wild and urban interface, the area where basically flammable vegetation intermingles with houses, has grown by almost 50% since the 1990s. So this is one other reason why fire is unfortunately in the media so much, because of course death and destruction is what attracts us to watching the news. That brings the news viewers really. So with that, how dangerous is it actually? And this is a little graphic I put together with the latest data from what's called the International Disaster Database. It basically looks at all disasters, whether they're natural disasters, whether they're other disasters, and it doesn't include all the data. Basically, there will be wildfires where people were killed, but they were not classified as disasters. They were too small, or perhaps no international help was needed, or not enough people were killed. That sounds very tragic now, but it's basically a few deaths will not be included in this database, but the trends are pretty interesting here. Since the 1980s, basically, despite that global decrease in area burned, which is really irrelevant here, but probably more because of the increase in forest area, increase in population density in forest area, we see this big spike in, this is a 5-year average, but it's basically death per year over time. And if you think about this, we have fantastic communication, we have better aircraft, we have better firefighting, we have better evacuation, all this, and nevertheless, the number of people killed in wildfires is increasing. Now, quite tragic, but again, I'd like to put this into perspective, and I do apologize if it sounds a bit, off really, but if you put this into perspective, every year, 3,500 deaths in the US alone in fires. So this is primarily building fires, and we're actually really good these days to stop building fires. And I don't need to talk about building fires in the UK, we had our own disasters here. 3,200 deaths per day in road traffic accidents. We're becoming better and better in protecting passengers in cars, but nevertheless, we're kind of accepting of this. This is kind of normal. Nobody blinks an eye unless you are affected, and it's tragic, of course. It's less than 1 per day in wildfires globally. That's not to say that if every death isn't one too many, but nevertheless, it really does put things into perspective. But let's move on from the rather morbid discussion here, although we'll stay with this a little bit. The direct deaths are actually relatively small in comparison to the other effects that we see. These are estimates, it's quite difficult to say, but it's estimated that's actually more than 300,000 premature deaths occur from just wildfire smoke exposure. I'm not talking about other smog, other air pollution, just wildfire smoke. And that doesn't mean that people drop dead because of the smoke. It is obviously premature death, people who would normally have lived a longer life, but they are dying prematurely because of wildfire smoke exposure. And that is quite a significant problem in many areas we don't really hear that much about in the media. So the question then really is, if this is where I belong, very tragic of course. Not sure whether somebody lost their lives, but they certainly lost their property, their livelihood. Very tragic if this happens. But should that house be there? Well, President Trump has an answer. It's basically the Forest Service is at fault. Now this goes back to the campfire at his previous presidency, 2018, Paradise, very aptly named town. The whole town was decimated basically. And interestingly, you can actually see, again, a little digression here, each house ignited the next one. The trees are hardly harmed. Okay, so really the main fuel in this is the houses and not the vegetation, even though the fire was started in vegetation by electrical fault. So anyway, yeah, so Trump thinks there's no reason, or did think, no reason for these massive, deadly and costly fires in California, except that forest management is so poor. So there's clearly one body at fault. It's the forest managers. They haven't managed the forest properly. And what he also said is that basically they should rake the forest more. He visited the Finnish president, and apparently they're raking their forests in Finland and to prevent forest fires. The Finns were quite amused about this, because they're actually not raking their forests. They don't have a big problem with wildfires, and there are various reasons for this we can talk about later, but yeah, they were rather bemused about this. So is there any truth in this? Well, that's me, and I'm raking the forest. I think I'm doing a pretty good job here. And this has to do with fire as well. So maybe there is an element of truth in this. And we are raking the forest for a small prescribed burn. So what we're doing is we're just raking 1.5 meters wide, remove the leaves, and we then ignite the ground. And this was done by the Aboriginal population in the past, and this is now done by many forest managers in Australia at the right time of the year when the fire danger is low. So that means the fire is not climbing into the trees. And this is basically what the fire looks like. Little slow motion video, but you can see the flames are about this high. And in that case, the flames will not jump over the area that we've raked. So yes, raking does actually work, but only up to a point, of course. So we actually approached at the time by The Independent to write something about this, because the comment hit the news so much about raking, and was there any truth in it? Is it the Forest Service at fault? And so we thought, okay, let's dive into this a little bit more. What's going on in North America, especially the US? Is forest management to blame? And yes, forest management plays a big role in many fires in the United States because of this fire suppression for 50, 60, 70 years that allowed more flammable vegetation to accumulate that would have normally burned in milder wildfires or native population wildfires in the past. So we wrote this piece, and we basically wrote, poor forest management only plays a minor role in wildfires. In fact, in this particular wildfire, in the campfire in Paradise, it played essentially no role. In fact, the forest nearby had been managed quite well. So we were quite happy with this piece, and then the next day, there was another version published in the app, a shortened version. And this is what it said. So when I saw this on Sunday morning on the app, I thought, what? No. So I rang up The Independent straight away, and the editor above the editor, who was basically dealing with the piece the previous day, he just took this, read a couple of the headlines, thought, oh yeah, Trump's right, okay, let's put it online. I was unimpressed. And then they changed it, Trump's wrong. The rest is exactly the same, all right? So next time you read a newspaper article, I'm not blaming The Independent, but take it with a pinch of salt. Okay, the story goes on. Now, of course, Trump has been in charge again. Oops, sorry. And, somebody else's fault, of course. Los Angeles fire, so this was in January. Completely incompetent fire service. They just don't manage the fires properly. Of course, there's somebody at fault. It's always one particular body, or perhaps even one person. He was certainly right in saying that many more will soon be lost. Yes, there was some truth in it. But let's just have a look at those fires. What actually happened? In terms of the overall impact, they destroyed over 16,000 structures, and of course many were very expensive. This is why the insurance losses were so high. The largest insurance losses actually ever recorded in terms of number of structures destroyed and total insured and economic losses. Insurance market estimate losses of about 40 billion, and the costliest year for global wildfire insured by a significant margin. So this exceeded the normally much more expensive earthquakes, tropical storms, flooding, and so on. So it was a big impact for the insurance industry. Now, what actually happened in those fires? Many of these areas around LA and also other areas of coastal California basically are what's called chaparral shrub. This type of shrub typically burns every 30, 40 years or so. Very oil-rich plants burn extremely well. It's not that long ago, a few decades ago, when the US Forest Service said this should not be a place where anybody should build houses. Okay, what do we see? Plenty of houses in this area. So the other thing that's happened is California had been under quite a long-term drought, but then recently they had good rainfall, so 2 good recent growing seasons, so there was a lot of vegetation in the area, basically. California, you might have heard about this, the area of California is exposed to very strong seasonal winds. They're called Santa Ana winds, and they basically blow from the inland. They usually come October, November, December, and they bring very warm and particularly dry temperatures, but they can reach up to 100 kilometers an hour. So it's not that unusual. These winds occur every year. But one of the things that really happened in this particular year as well, after those two good growing seasons, the summer drought that would normally happen in this Mediterranean climate, that is normal to have a summer drought. That's why people want to go to California or to Spain in the summer or to Greece, Italy, and so on. It's the Mediterranean climate, the only climate in the world that has a summer drought, and it's usually quite reliable. Unfortunately, that extended into winter. So basically, it was ideal conditions for a wildfire. And also, of course, we have this enormous wild and urban interface. Plenty of houses built in areas that are extremely flammable. Now, what do you do about this, or what could be done? So what would normally be done, of course, this is what you see on television, more planes. Can this be fought by more planes? I just left a question mark here, and I'll come back to the fires in a minute. Early detection of fire, there's a lot of discussion now about satellite, about drones, ground-based cameras, AI. They will save us from fires. They'll fix it. They will certainly help, no doubt. I mean, there's some cool technology out there. But the best technology to stop a wildfire is actually this, a bulldozer. Not always, but in most cases. What does the bulldozer do? It's like raking, but on steroids. And in this case, you can basically just generate a fuel break or a fire break, and essentially that the fire, with some luck, will not breach. This is the way to stop a wildfire. The aircraft will do relatively little in those fires. They can protect some areas in particular, around houses perhaps, or other important infrastructures, but they will not put out a big wildfire. Whereas these, they will put out a big wildfire because it'll burn itself out, if you're lucky. Now let's just have a look at some physics again, or essentially physics. And this is the image I showed you earlier of a fire in Canada in 2016. Huge flame length. There's a lot of energy release here from this. This is one of the highest energy releases you would see, like 50-meter high flames. And here on the left-hand side, you can see what's called basically the fire intensity in kilowatts per meter. Okay, so let's just have a look at the scale. Now, what's really important with all this is basically above an intensity of roughly 4,000. In the extreme case, maybe even 10,000. Let's say 10,000. Essentially, nothing you can do about it. So that basically means aircraft, anything else to try and put the fire out actively is not going to work. Okay, so that's a really important thing to consider. In Britain, to attack a fire, basically it's somewhere down here. Flame length up to 1.5 meters. You can send a firefighter close to those. Anything higher than that, forget it. Just can't do it. So that's the context. Now, we actually did have a look at some of the fire behavior in Los Angeles fires in response to a press request. And we did this doing a tool that we developed in a UK-based project, which was aimed at developing a fire safety rating or fire danger rating for the UK. And one product from this is basically a model. You can click on the map and see what, if something burns, how would it burn? How big are the flames? How quickly does the fire move? And it's designed for Britain. Gorse, for example, here, heather, grassland, crops. But we played with this as well for California to see what was going on, because even though the fuels are somewhat different, the chaparral shrub is different, but it's probably closest to gorse in terms of its behavior. So what we saw, for example, on the 8th of January is super low relative humidity, here 7%, wind speeds, and that is in meter per second, 18 meters per second. And so basically what we see for the shrub fuels for this particular period in the day, for this particular location, and it considers topography and so on, you can click anywhere in the map and find how it would burn in this tool. You basically get flame length of over 11 meters from shrub that might be like 2 or 3 meters high. There's no way you can do anything about it, basically. And so Yeah, here what we actually seen in reality is flame length of over 10 meters. And this is another thing that happens in those fires because these extreme winds, let's see if that video works. A very poor video, but what you can see here is the fire is behind the hill on the left, and suddenly you get these embers coming right over the hill and igniting the next area. And this is something very typical in extreme wildfires that occur under high wind speeds, that you get ember transport, so basically embers that fly sometimes long distances. In Australia, there have been observations of embers traveling up to 20 kilometers. And you could imagine, if you're a firefighter, there's nothing you can do, absolutely nothing you can do about that. And so here's a statement of one of those responsible with dealing with fires, not directly, but I would say indirectly in response to Trump's accusation of what had happened.
On that question, how do we prevent this from happening again? And that's going to be very, very difficult because we've had a lot of discussion and there's been a lot of review about the number of fire engines, the number of firefighters, how long did it take to get on scene, did you have water or didn't you have water? What we experienced here was a community conflagration. Much like Lahaina, the Marshall Fire in Colorado when there was snow on the ground and fire moved from house to house, or Paradise in Northern California. What was different this time is that a community conflagration occurred in a metropolitan area. LA City and LA County Fire, over 200 fire stations. We have 9,000 firefighters in the Los Angeles County area between the 29 departments. The challenge now, like Chief Hudson said, is going to be to build fire-wise communities. It's to make sure that when we rebuild, which will occur, that those structures are standalone. That a firefighter or a fire engine is not going to need to be at your home for it to survive. We need to make sure that defensible space is appropriate and that it's enough. And lastly, due to climate change, we need to manage our wildfire ecosystem. What we've essentially done in Los Angeles County is remove fire from the natural environment. When the native first peoples were here, the fires burned in these hills. And they even had cultural burns. We now no longer allow fire to propagate naturally. So when it occurs under 100-mile-an-hour winds or 70-mile-an-hour winds, it is impossible for Chief Crowley's firefighters or for my firefighters to put that fire out.
So yeah, I think that sums it up really well, a very honest assessment indirectly in response to the accusation of not having enough resources, not doing it well, and so on. Now, it's actually nothing new that these houses are essentially not designed to withstand fire. And the laws actually exist to do this. And the zoning exists as well. So zoning exists, for example, in California, here in Los Angeles. Los Angeles in particular, the wildfire risk is very high, so it's got a risk score of 99.9%. So we think, well, all the houses are built in a way to not burn. Well, yeah, that's wishful thinking, of course. They are not. It's probably the opposite compared to the houses we have here in Britain. They're extremely flammable, and yeah, maybe that's quite a good summary here. Criminally reckless, but of course only when a fire occurs. How often will a fire occur in this area? Well, it will occur again, undoubtedly, but maybe not for another 10 years or so, and I can't afford to buy, or to buy those materials, fulfill those regulations, and so on. So it's complicated, but the principles are well known and well understood. And for example, California law does require a particular way of dealing with the fire risk in the landscape, and that's not just fireproof building material, but primarily also, and there's little things that are not that expensive, to basically keep your property or the fuel around your property, to keep the fuel accumulation and the type of fuel in a less flammable state. That doesn't mean it will not ignite under all circumstances, but it improves the chances of your building not catching fire. And so here's an example that hit the news quite a bit in the Palisades fire. This building, of course, it is more expensive than another building, but you can see everything else around it has burned. And the house is still standing. Yes, it is quite an investment, but perhaps a good investment to do this. You can also buy a fire bunker. There's an Australian company who does that. Now, whether you want this in your garden or not, well, maybe you do if you live in some of the eucalypt forest areas in Australia. $15,000, you know, that's a good second-hand car. So maybe it is worth an investment. And I can imagine this probably will be sold in some areas of the US as well in the future.
Doesn't that look like an oven?
Yes, it's well insulated, and of course there is airflow, but it's basically, yeah, it's well insulated. The fuel is outside rather than inside. In the oven, the heat comes from the inside, and a wildfire comes from the outside. Sorry? Yes, this is designed to be underground, but I don't know the specific design. It may actually survive above ground as well. There are people who have built their own fire shelters in Australia, DIY. Some of them work really well, but it might be better to use a professional company. Anyhow, what else can we do? Now, managing the fuel is definitely one thing that can be done. This is something that's done quite extensively in Europe and has been done in Australia for quite a long time as well. To burn the landscape under low fire weather, basically remove all the very flammable material. That means if there's a fire in the summer, or if the conditions are right and there's still a fire in the summer, it will not be as severe, it will not travel as fast, it's easy to put out. Or with some luck, it won't even ignite. Still expensive, but something that can work very well, at least up to relatively extreme conditions. But also, what's happening with climate change? So let's come back to our original question, basically. If we look at the fire weather for the future, we unfortunately really are only at the beginning. So this is basically a summary of different model outputs, where the length of the fire weather season is being modeled. This is the average, this gray line here, basically. You know, we are roughly around here. We do see a relatively steep increase, and this is for different areas: Pacific Canadian forests, Pacific US forests, Southern Amazonia, Southeastern Australian forest. And what's really frustrating on this is actually that line here, that purple line, is essentially the reality that we're already seeing. If you have any more questions about this, you can ask Matt, he's behind this. But basically, the key thing is our climate models are actually lagging behind in terms of predicting what the future fire weather is going to do. So the reality is likely to be steeper than this average curve, whereas this is basically the different fire models, you know, the big variation between different climate models, not fire models. So yes, it's going to get worse. Fire weather is going to get worse. There's no question about it. It doesn't mean we're going to have more fire everywhere, but the conditions that make the landscape fire prone, they're definitely going to increase. Now, just to give you an example here from the most destructive fire we've had in recent history in the UK, one particular day in 2022, and the fire weather, bit of a complex graphic here, but basically we plotted here the fire weather per day in terms of the fire weather index, which is just a numerical index, very high to very low. So this is January 2000 to 2022. And basically, you can pick every day. So 2011 was quite extreme here, right? 2020 was quite extreme. But basically, that one day where we had across the UK 60 properties lost due to wildfire has been off the scale. The highest level we had before was 62, and it jumped to 75.4 in terms of the fire weather index. And in Germany, for example, which is not really known in the media for extreme fires, we had also quite extreme fire here. In 2022, and the highest one before, same year, of course, 2011, 69, it jumped to 85. So again, climate change will have an impact on future fire probability, without a doubt. So what can we do about this? It is inevitable that fire risk will increase in most regions, okay? Again, that doesn't mean they will all burn, but the fire risk will increase. Of course, you know, you heard this a million times, and we just had COP, so I'm not going to go into too much detail, but yes, having more carbon emissions in the atmosphere or to the atmosphere is not a good idea. That will help long term, but we're already on a trajectory of more, without a doubt. Education. One thing that we haven't really tackled is that we want to live in a green space. Do we really need to live in a green space that's highly flammable? Maybe we do. We also live in floodplains that flood all the time. That's our choice, but we need to then accept the risk of fire. Management. Let fires burn where they are natural. and reduce the fuel elsewhere. I think that is something that can be done so long as fire stays in the forefront of our minds, and it doesn't often do because it's very episodical. There may be 5 years without much fire where you live. There may be 20 years or 80 years or 120 years where you specifically, not pointing to you as the audience, but in general, even if you live in a fire-prone area, it might not affect you for a long time. So we're likely to forget things. But also change the attitude. Fire has been on the planet for a long time and will remain on the planet for a long time. We use it for all kinds of purposes. We're benefiting from it enormously in terms of fossil fuel. We also have our big problems with that now, but nevertheless, the combustion process is something that we lived with for a long time, and it will maintain, it will be around for a long time as well. So we just have to accept fire will be in the landscape, and we have to deal with it, essentially. And so with that, do we have a global wildfire crisis? I'm not sure what the answer is, depending on where you live and what you consider a crisis. I'll let you dwell on this or answer this yourselves. I'm not saying we necessarily have a global wildfire crisis, but what I would say personally, yes, we do have a wildfire crisis in many areas where we shouldn't have one. Thank you.
Oh, thank you very much for that, and we can take some questions now. So, as usual, I'll start off in the room, and because there's an online audience, could you please raise your hand and wait for the microphone, and then speak directly into it. And after some questions in the room, I'll see if there are any online. All right, at the back.
Hi, thank you. It was really interesting. I'm not an academic, so I might ask something rather silly, but you talked about savanna in Africa burning every 1 to 5 years.
Yes.
And so the flora has adapted. Can you say anything about how the fauna has adapted to that?
Very well adapted as well. I mean, what you typically see after savanna fires is that some small creatures will unfortunately not survive. So, for example, some snakes, you find some poor scorched snakes, for example, after the fire. But the ecosystem is so well adapted to fire that essentially does not really affect the survival of any species because they've been so long living in the fire. And in fact, what you often see, what we also observed after fires that we set for experimental purposes, and that's been done for a long time in the Kruger National Park, is that animals move into the burned area for a range of reasons, one of which is zebras, for example. They really like it because they can see the lines. So actually they really benefit from it. There's also something that's typical for savanna regions, and it's only more recently been recognized as truth that some birds will pick up burning sticks, fly with them, and start a new fire in order to hunt for animals that flee from the fire. It's really smart, and again, that's probably been around for quite some time in terms of evolution, but yeah, the ecosystem is just really well adapted, whilst, of course, you do see individual death from fire. Fire is deadly for some, absolutely.
Thank you very much. I've learnt a lot. I'll forget quite a lot of it as well, but I'll hang on to as much as I can. I think I want to answer your question. Yes, I think the crisis is enormous. There's implied in everything you've said ecosystems and the dreadful impact on ecosystems. You haven't addressed, I'm not criticizing you, I'm just saying, but there are an enormous number of implications in these fires. In other times, they could have come back and survived. But the loss of species of all kinds, flora and fauna, has to be affected by this. And it seems to me it's feeding into the crisis and making it a global crisis of enormous importance.
Yeah, I mean, absolutely right, and again, depends on which angle you're looking at. If you look at ecology, it is a crisis. Take, for example, again, the Black Summer fires. 10 times the normal area burned. The forest already under big drought. That means the forest is already stressed, and there were a whole range of species that are assumed to have been driven to extinction. The jury is still out on some of those, but because there's been so much stress already due to that drought, and the area's 10 times larger than normal, there's not that much unburned land around, essentially. So it is those less extreme wildfires that burn over relatively small areas that can be ecologically beneficial, especially obviously in areas that are adapted to fire, whereas those really extreme ones, high burn severities, large areas burned, very few corridors left that are unburned, of course, yes, they lead to species extinction, or at least a drop in individuals, which can then be stressed perhaps due to other factors as well, being hunted out to extinction or something like that. So absolutely, I think you're absolutely right.
Thank you. Yeah, really interesting talk. Thank you. It was really good. Maybe I got a bit lost as to whether raking was good or bad. Sorry. So I'm wondering, do we know what is the kind of right amount of vegetation to leave in the landscape, or dead vegetation to leave in the landscape? So I'm thinking from an ecological point of view, it's good to have leaf litter, it's good to have dead wood. From a biodiversity point of view, it's also good in terms of soaking up, excess rainwater. So is there a potential trade-off there, and or do we know what the right amount is?
Yeah,
does it depend on the habitat?
It's a really, really good question, and I don't think there is the answer. It's a matter of perspective. What is the right amount for what you would like to see, basically? And I give you a really interesting, well, I hope it's interesting, example from Germany, where a large area of forest was basically destroyed, stand replacing fire. In the end, all those trees will fall over, complete mess, basically. And then there was a question, shall we remove all that wood? Yes or no? And then the researchers actually asked for some of it to remain. They did some investigation. It was much cooler under those areas, so regrowth was much better. Then you remove the wood. It kept the deer population out. The German forests are overpopulated with deer, so the deers couldn't graze in those areas. So it seemed like a win-win, really, really good thing. And then there was another really dry summer, and then fire went through that area again and actually burned with quite high severity, because this huge amount of dead material burns really well, whereas if it is fresh, it doesn't. But dead trees, once they're dry, they burn really well. And what is the answer there? Really challenging. So I guess that there probably is some agreement in some environments what the ideal amount, but you will always get some scenarios where you can't be sure. In a sense, we have to do our best. But I think one thing is clear: by keeping fire out of the landscape where fire was normal in the past, this can't be right. In Britain, it's much more complicated. We don't really have a natural fire regime, and you're probably aware of that. There's a massive debate about whether we should be using fire to keep our moorlands open and to keep our heathlands the way they are, but I don't want to even go into this. A highly complex and very emotionally loaded discussion.
Right, I'm going to go online for a couple of questions. Stuart Reynolds asks, global heating will increase the average temperature, but the response in terms of weather and rainfall will not be uniform. In some places, the rain will increase, in others, it will be less. Maybe the incidence of fire will be more influenced by rainfall than the temperature. How good is our modelling of future rainfall patterns?
Very good question. I don't think I'm the specialist to answer this, but basically for every degree of warming, you need 15% more rainfall to make up for the excess moisture loss. So in principle, you can have areas in the world, absolutely, where precipitation is increasing, and there is one spot actually in Africa, just southwest of the Sahara, where rainfall actually is increasing, as far as I know, due to climate change, and that might actually reduce fire up to a point. It's challenging, though, because if we have good rainfall in areas that are usually rainfall deprived, it also leads to more vegetation growth. And then if you have a drought, it can burn more. So it's undoubtedly complicated, and it's undoubtedly wrong to say that fire will increase everywhere, as I said earlier, because rainfall patterns will also change vegetation. And then you also have to think of ignitions. We know that climate change is actually increasing more lightning. Lightning density is increasing, lightning strikes are increasing, and that in turn obviously increases the probability of ignition. So it's highly complicated, but overall I think we have good agreement that we're going to see more fire in the landscapes that are susceptible to fire around the planet due to climate change.
Right, there's a comment and then a question online, and then I'll come back to the room. So the comment is from Wesley Steed. He says, thanks, Stefan. The FPWES site survived the wildfire near Providence this season.
Yes, I know, which is amazing, and probably means nothing at all to the audience.
Well, exactly. But can you explain?
Let me explain very briefly. Wesley Steed, a fantastic Canadian, call him fire chief, responsible for fire suppression, but also responsible for helping us to actually investigate wildfires. There's one place in Canada in the northwest where forest parcels have been set aside to burn. So we can go there, and Wesley and his team set those forests on fire for us. We can do all the measurements that we want. It's the only place in the world where fires are carried out on a regular basis for research purposes. And twice now, in the last decade, there were big wildfires in the area where there was a risk of this site to be consumed, which would be a shame. It'd be a drop in the ocean in terms of Canadian wildfires, but for science, it would have been a disaster. And this summer, it got very close. We worked there this summer. We had a fantastic fire. This is actually one of them. This is one of the fires. Wesley was there. So thank you, Wesley. And yeah, these are amazing, basically. And these will carry on because that site was saved from wildfire.
And Andy Moffat asks, hi, Stefan, what might be the most important change in policy in England that the appropriate Secretary of State might take forward to reduce the risk of future wildfires exacerbated by climate change? Do you want to suggest more than one? P.S. Great talk.
Yes, thank you, Andy. That is a loaded question in a sense, but I think a very good one. So what I like to see, and I think a lot of us who do research on fire would like to have change, is basically when it is allowable to burn in the UK. We basically have a fire window where fire is allowed. You still need permission to do so, but this is essentially too short. Weather's so erratic, it's very difficult to have a prescribed burn in that allocated period. And so there needs to be more flexibility in this period. So that will be my number one wish for the UK management of fires.
Okay, back to the room for questions. Right, I'll go to you first.
Okay, thank you. Thank you, Stefan. That was a great talk. You said that fires create their own energy.
Yeah.
Can you comment on that? If it translates greater wind as a pilot, that's sort of interesting to me. And secondly, I saw some phosphate being dropped.
Yes.
What are the implications of that on, well, firstly, it's rumored to be carcinogenic, but also what are the implications in terms of the wildlife, plant life as a result?
Okay, let me answer the second question. There's been a lot of debate actually about fire retardants and whether they are safe to use, and they are becoming safer and safer essentially. So ecologically, I would argue there's not that much of a problem in terms of using them, especially as they're used over relatively small areas. I would probably more say it'd be much better not having to use them. There are many other ways of actually preventing this. Also, if you think about the aircraft, they're really expensive. A lot of firefighters actually die in aerial firefighting. And so again, we should avoid this as far as we can. So from that perspective, I think we should ending up with using less and less retardant in the future by better landscape management and also by better property management, because if the houses don't burn down, we don't need aircraft to protect them. And sorry, your first question was about fire rated power.
The energy generation.
Yeah, in the fire.
Specifically in terms of wind, or
Yeah.
is it more an increased momentum?
Yes. Okay. So now, yeah. How much time do we have? It's fascinating. I love this topic. It's complicated. So basically, there are a number of factors that affect how fast a fire moves and how much energy it releases. The faster a fire moves, the higher the rate of energy release. And of course, the more wind you have, well, I can blow out this candle, but it's not going to happen in a wildfire. The extra oxygen will basically help the fire burn. But also, if you actually have a strong wind and you blow that flame forward, it's closer to the ground. It'll preheat any of the fuel that's here. So a flame is like this and moving can actually make the material in front of it much drier than it would normally be for a flame like this. So that accelerates the fire. So wind basically leads to a much greater rate of spread, energy release, on energy release rate in particular. And then the other thing we have to consider with this, is, which is often forgotten, but it's actually a major cause of death in wildfires as well, is if you have a steep terrain, you have a similar effect. So when you have a flame here, it will basically preheat everything that's on that slope, much better than if it would be flat. And that means if the fire moves up the hill, it accelerates. So those two factors, for example, lead to much more intense fire. By intense I mean the energy release rate. So this is one of the many factors that affect fire intensity. But also when humidity changes, for example, you can really see that, again, in those Canadian experiments, when humidity fell from, let's say, 40% to 28%. The way these fires burn is an enormous difference over that relatively short, window, if you wish, of humidity. So, yeah, there are lots of effects. Not sure I answered that question, but...
Thank you.
Yeah. So if I could add a question, does that mean that if you have a lot of sort of fire-friendly weather, you could actually issue warnings to people in some communities that there's a very high danger and that they should perhaps evacuate?
Yes. Now, okay, evacuating, that's a different story. But basically, here in the UK, we actually did, and we still have it in a sense, but I would say it's less reliable and almost obsolete. Maybe that's too bold a statement, but it's basically the Met Office Fire Severity Index, which has now been moved away from the Met Office. And basically, this is a purely or primarily weather-driven index. If a fire would occur, it could be pretty bad. And now many countries have this in Australia. For those of you who travel to Australia, you will have seen that. There's signs next to the road, fire danger very high, fire danger very low, and that is related to the weather. But of course, that just means you need to be prepared. If you want to evacuate everyone every time the fire weather is high, basically, well, you'd be evacuating all the time. So the real challenge here is to evacuate people at the right time when they're becoming at risk. And for this, essentially, you need an ignition first, and then being able to model how quickly that fire moves into that area and whether or not there should be an evacuation, because every evacuation carries risks as well, and of course costs, disturbance. So it's a real challenge, but the systems are getting better and better in terms of predicting what should be done if there is an ignition under certain conditions, basically.
Thank you. That's been really interesting. I just wanted to ask, I grew up in Scotland and there's fire breaks everywhere. So is there any legislation, and should there be any legislation, given we're planting lots of new forests all over the world, in the new forests we plant having automatic fire breaks and the angle of them? So for instance, in Scotland, a lot of them go up the hill, so that the little bit burns up, but you've got a bit beside it that doesn't.
Yeah, if we come back to what we have here, for example, in the UK, we have virtually none of this, even though this is something we should actually think of more and more. And I'm sometimes amused, be it in Wales or somewhere else, you in the forest, and then you see the totally overgrown sign, fire danger, and then sometimes you even see a fire beater. I don't know if you've seen that. Go walking in the forest and you see this stick with a bit of rubber at the end, and that's basically designed to put out a fire. Can be actually very effective. You can make your own little fire break with this, basically, or you can certainly put out the fire if the flames are very low. But I think in many places around the world, we need to invest more in those fire breaks, and those fire breaks, they need to be maintained. That's another thing. And of course, everybody wants resources for everything. Do we have the resources? Are we willing to spend those resources? I think therein lies the biggest challenge, because I think in terms of what we know to prevent fires to become disasters, and I think that's the key thing, we want to prevent fires from becoming disasters, we actually know what to do. Is simply implementing it and having the resources and the will to do it.
Right. It's you next.
Thanks. Thank you. That was a really good talk. Why is the popular term for these fires wildfires when a lot of them are actually caused by humans?
That is a really good question. There's a lot of debate at the moment. For example, in the UK, at the moment, how we should define wildfires. And one of the editors of the International Journal of Wildland Fires, we on purpose use the term wildland fires because these are fires that are basically in natural vegetation, semi-natural vegetation. I think the term wildfire is not a good one. So in a sense, I totally agree with you. Just a question, what should we use instead? I think we should use vegetation fires for all of those. But I think the term wildfire, many people associate that with an uncontrolled fire. And of course, those disasters are totally uncontrolled fires. So in that sense, I think it evokes the the right kind of sense of what they are. But generally speaking, yes, we should talk about vegetation fires. So I do agree with you.
I'm definitely another non-specialist. So you mentioned one of the dangers that people notice most was smoke.
Yes.
Especially in the terms of the American fire.
Yes.
I was thinking more about India and about the real problem, which you seem to be suggesting, of people not having abandoned traditional methods of burn in agriculture and still maintaining it, and coming into conflict with the difficulty of cities and smoke pollution. Can you say any more about smoke?
I think you're touching on a huge problem, because if you think about how many individuals, often women of course, but let's just say often families, are still heating their home and cooking in a confined space with a wood or charcoal fire, they're constantly exposed to this. And on top of this, they're exposed to more wildfire smoke. So you could argue what's more dangerous, but of course we know more and more now how dangerous smoke is longer term in terms of mortality, cancer rates, cardiovascular disease, and so on. So that's definitely a big problem, both for wildfire smoke and any other sort of air pollution. Big debate at the moment in London, how should you allow wood burners, and actually, in fact, in other areas in the UK, probably here in Bath, I don't know what the regulations are. But yes, smoke is dangerous. The only other thing I would say is that actually we have been sitting around campfires and been using fire to heat our tents, small huts, and so on for a very long time. So I'm not suggesting it's not dangerous, but again, this is something where we basically, I wouldn't say we adapted to it necessarily, but it's something we live with for a long time. And if we can get rid of it, great, right? But wildfire smoke is something we will not be able to get rid of it, and it's one of the big problems that we have when we conduct prescribed burns, because people, they want the prescribed burn to reduce the fuel, but they don't want the smoke. If you are a grape grower, have a winery in Australia, you don't want any wildfire smoke ruining your wine, but you do want the wildfire smoke stopping the extreme wildfire to occur. So it's a trade-off. We will have smoke, but at the same time, yes, we should reduce smoke exposure as much as we can, without a doubt, because it is unhealthy. And that includes smoking cigarettes, but I'll leave it there.
Right. There are no more questions online. Wesley Steed's anxious to be able to get details of the recording of this talk. Any more questions in the room?
Thank you. Just a quick question. Is there anything we can do to help the areas recover after the wildfires if they are going to be more of them? What can we do to make things come back quicker?
In which way? Because there's so many aspects in terms of wildfire recovery that are a real challenge, basically. So do you mean the landscape, the vegetation, or...?
Any of it, really. How much effort are we putting into, so we've got this problem and it's not going to get better, so so we're going to have to live with it for a while.
Yeah.
What can we do to reduce the impact of it or to get it better quicker?
Okay, let me try and keep this short, but basically there are two things. In some areas, they are trying desperately to replant, to do all kinds of things, basically, and it's often not necessary because nature will often recover very, very well. But then there are other areas where fire has been too extreme, where basically reintroducing species, seeding, for example, or sometimes just mulching the forest actually really helps in that respect. But let me just think of something else at the moment. If you live in an area where you have every summer smoke exposure or something, your recovery essentially becomes an endless, I would almost say, trauma, because you're all the time exposed to smoke, and that's very challenging to deal with, for example. Or if you have to evacuate for the fourth time in a summer season, if you live in some areas in Australia, for example, that's the case. That is really challenging. So I think for some people, and in some areas, they just shouldn't be inhabited, to be honest, because people should just not be living there. But again, I said that's about floodplains earlier. In Britain, we've built floodplains all over the place, and I'm not blaming anyone, but this is what we've done. So we have to be accepting of certain issues that we just have to live with.
Right. Well, that looks as if we've come to the end, and it's just in time because it's just before 9 o'clock. Now, I mean, I've learned a huge amount this evening. I had no idea about all these complexities around fires and when they're good and when they're bad or catastrophic, and all the things that could be done to mitigate or avoid them. So I really appreciate the talk, and I'm sure you do too, so let's show our appreciation.